Welcome back. Cache. A cache is a high-speed data storage layer that stores a subset of data, typically transient, so that future requests for that data are served faster than by accessing the primary storage location or the primary database. So caches are in-memory storage, so it's way more faster than a normal database server. So we use it to enhance the performance, scalability, and reduce the latency. So it will get us into more user satisfaction, and will improve the performance, and we improve the scalability of our application. So let's take this as an example. So let's say that we have a server, and the server is sending a read or write request to the database. And the client will demand a read requests to the server to get a user info or something. And the server will try to send the read request to the database, and the database will send back the user data, and the server will send the user data or as a response to the client. And this looks quite well. There's no problem in that. But we're thinking about right now, could we make this process way more faster? The answer is yes, by using cache. So how it will work? The cache, we will store the frequently accessed data in the cache. So when the user trying to access, when the client trying to get the user, the server will get it from the database, and also it will save it in the cache. It will save the user info in the cache and send the user info to the client. So when the client try to send another request to get the same user, the server doesn't need to connect with the database or doesn't need to send any request to the database. Instead, it will send the request to get from the cache. And since the cache is in-memory storage, it will save it way more faster. So by using cache, first we improve the performance, like it's faster data access by storing frequently accessed data closer to the request. The requester caches significantly reduce data retrieval time, also reduced latency, like decreases the time it takes for data to travel between the storage and the requester, enhancing the overall user experience. Also, we reduce load on primary data source. So as you can see, and caches handle repetitive read requests, reducing the load on the primary data source or the storage system. So when the client tries to send another request to get the same user, the server will not send these requests to the database, and the database will not get overwhelmed. The caches will handle that. Also, the caches is great in cost efficiency, so offloading read traffic to the cache can reduce cost associated with high performance storage or database scaling. We increase the scalability because we're using efficient resource by handling frequent queries. Caches allow primary systems to focus on more intensive tasks or handle a higher write traffic. And also we enhance availability and reliability as well, because we provide a fallback mechanism. If the primary data source is temporarily unavailable, the cache will handle as a database for a period of time. Also, fault tolerance, so it helps in maintaining data availability during network issues or servers. There are multiple types of caches. There are the client side cache, there are server side cache, there are in-memory cache, and also there are multiple different types of caching strategies. There are the caching policies, caching invalidation. We have the write through and the write behind, and there are etc. And this one is behind the reason of the video. We will talk about the strategies of caches and which one to use, but in separate video. This video purpose is just to talk about what is a cache and why we need it. So in conclusion, caching is a fundamental technique in computing used to enhance performance, reduce latency, and also reduce the load on the primary storage. By storing frequently accessed data closer to the point of use, caches provide faster data retrieval, improve scalability, and ensure higher availability and reliability of applications. So yeah, that's it for this video, and see you in the future.